All right, guys, welcome to 5.4 exponential functions. Yesterday, we finished the differentiation portion, but you guys have the notes on the back side. You'll find the notes for integrating with e to the x. It's really nice. It was our favorite formula yesterday because it's such an easy one to memorize. And the inverse then makes it really easy too. This would be like asking, tell me what function has e to the x as its derivative. Well, the answer is e to the x. Don't forget your plus c. These lend themselves very well, because that's a pretty boring question, to u substitution. It is very easy to make a composite function where your exponent is itself a function. So you'll often see this kind of problem associated with your u substitution. It doesn't really change anything. You'll just have that added step. So here's some examples, right? Most of the time, not all of them, but at least the first two, you're going to look to your exponent to help you with your substitution step. So for example, on A, I'll let my u be 3x plus 1, and my du would be 3dx. If I look, I could rewrite this equation then, or this integral, as e to the u. I only have a dx, so I'm going to divide my 3 to the other side, and I'll have 1/3 du equal to dx. Well, the integral of e to the u is just e to the u. So this is 1/3 e to the u plus c. And I'll back substitute in 1/3 e to the 3x plus 1 plus c. A nice, easy question. B is very similar. In fact, if you want, take a moment, stop the video, and see if you can figure it out on your own. Okay, check your work. Did you let u be the cosine of x? If you did, then your derivative would be the negative sine of x times dx. And we're really, really close to having that, right? I have a positive sign, so we'll multiply through by -1. And when I go to do the substitution step, I would have the integral. E to the cosine x becomes e to the u. My sine x dx is exactly equal to -1 times du. If I integrate that using the rule above, I've got negative e to the u plus c, and back substitution, negative e to the cosine of x plus c. So two nice sort of easy questions. If you look at letters C and D, you'll notice that the coefficient, or sorry, not the coefficient, the power isn't really going to help you here because u equals x is a terrible substitution. It won't help you simplify anything. So these two work a little bit different. Letter C is kind of like a quotient rule. If I let my u simply be the denominator, then I can review the stuff from the front side. The derivative of 1 is 0. The derivative of e to the x is e to the x. And what do you notice? Right? E to the x dx is exactly sort of this leftover piece that I have. So everything I just circled in green becomes du. So this will be the integral. We'll come back to the bounds in a second of 1 over u du. I like to change my bounds. So I'm going to, on the bottom, plug in 0. E to the 0 is 1, and 1 plus 1 makes a 2. E to the 1 is just e. So the best I can do up here is write 1 plus e. That's okay. Totally fine. I've changed everything over now to u's, and I don't have to go back since I changed my boundaries. So I'm going to get the log of the absolute value of u, evaluated at 2 and at 1 plus e. This would be the log of 1 plus e. It's going to be positive anyways, so whether or not you chose to put the absolute values in really won't matter, minus the log of 2. You can't split this, okay? There is no logarithm that, there's no rule that says that log of a plus b is log of a plus log of b. Don't do that. I know it's tempting. The only thing you could really do, other than circle it and call it finished, you could take the subtraction if you really wanted to, and you could condense it to a single logarithm. But honestly, this answer or this answer, both of them are perfectly fine and totally equivalent. Let me try to sneak one more in here. Let's see. On this one, we essentially have a product rule, right? If I just let my u be the coefficient, it's not going to help me simplify anything. But I have an e to the x inside of the cosine function. So I'm going to let u be e to the x. du is also e to the x dx. And on this particular problem, we are in luck because that accounts for everything extra that's in my way. So I'm going to have the integral of cosine of u, and everything I circled in green is my du. Change of bounds, I'll have e to the negative 1, and I'll have e to the 0. Last but not least, right, what function has cosine as its derivative? How about sine? I changed my bounds, so I do not need to go back. And I would get the sine of 1. It's radians, if you really needed a value. And I'll subtract the sine. Maybe you write it as 1 over e, since it's e to the negative 1. Maybe you left it as e to the negative 1. Doesn't really matter. So a really short set of notes today. Try them out. It is much different doing them on your own than it is just watching me do 4 of them really quickly. But you have all the rest of the time to work, so use it wisely. Or if you're watching this at home, start your assignment on your own. Thank you guys.